are sequential reactions taking place in a sequence. In the first option, you have 100 ml. So in liter, it will be 0.1 liter. Moles of CO2 produced are 2 minus x mole. Hello dear students, welcome to Allen Overseas and welcome back to the very important series that we have started is 45 important topics in 45 days, okay? And this very special series is divided into 3 parts, that is 15 topics from physics, 15 from chemistry and similarly 15 from mathematics, and I will be discussing this chemistry part with you, right? And this is how we are going to cover our total 45 topics in 45 days. So let's continue with this chemistry part and let's see what is our next topic. Sequential and parallel reactions, that is taken from the chapter mole concept. Fine. So first of all, we have to understand that what is sequential and parallel reaction, right? And then we are going to solve few important questions also from these topics. So let's see. Okay, first of all, we have this sequential reactions. So what are sequential reactions? Sequential reactions are when you have 2 or more reactions and one of the product formed in the previous reaction is consumed in the next one. Okay, so first of all, as the name is suggesting, sequential reaction means we will be having more than one reaction, right? And these reactions will be taking place in a sequence. When the first reaction completes, then the second will start. When second completes, then third will start and so on, right? And one more important thing, the product of first reaction will be the reactant of second reaction. Similarly, the product of second reaction will be the reactant of third reaction and so on, right? For example, if we see this reaction, here we have A and B as the reactants which are reacting to form the product C and D. Okay, now you can see this is the second reaction here. C is reacting with E and forming F and G. So here you can see this thing that the product C of the first reaction is the reactant of second reaction. This is the first reaction, this is the second reaction, right? So these two are sequential reactions taking place in a sequence. Now very important thing about these reactions is that moles of C produced in first reaction, this will be equal to moles of C participating in second reaction. Okay, this is a very important part about the sequential reaction, that whatever amount of product C, whatever moles of C will be produced in the first reaction, that same number of moles will be taking part in the second reaction. Okay, now here you can see that the stoichiometric coefficient is same. But even if the stoichiometric coefficient of the balanced reaction is not same, still the number of moles will remain same. Okay, number of actual moles which are produced in the reaction and number of moles participating in the next reaction, they will be same. Doesn't matter what is the stoichiometric coefficient, right? So fine. Now what will be the method to solve such kind of reactions? So such kind of questions. So the method is very simple. We have to use the basic concepts of mole, basic stoichiometric concepts, and this is very simple, right? How? Let's see. Let's solve one question related to this concept. Okay. So this is the question. Ammonia gas released on quantitative reaction of 0.6 gram urea with sodium hydroxide NaOH can be neutralized by. Okay. So here what the question is saying, here it is saying that we are talking about the quantitative reaction of urea. Okay, urea is reacting with sodium hydroxide and during this reaction ammonia gas will be produced. After this reaction, ammonia is the product, so ammonia gas is released. We have to find out that how much HCl will be required to neutralize that ammonia. So this is the example of a sequential reaction. So what should be the first step to solve this question? The first step to solve this question will be to write the balanced chemical reactions first. Okay, so first of all we are going to write the balanced chemical reaction. So we have urea, that is NH2CO, NH2. Urea is reacting with NaOH and it will be forming ammonia, NH3 plus sodium carbonate, Na2CO3. These are the products of this reaction and we have to balance it. Here you have 2 NH2, so here 2 ammonia will be formed and Na2CO3, so 2 NaOH. Now this reaction is balanced. Okay, fine. So okay, we have 0.6 gram of urea. So first of all we have to find out the moles of urea. Okay, moles of urea. So how we can find out? Moles of urea will be 0.6 gram divided by molar mass of urea. Molar mass of urea is 60 gram per mole. 60 gram per mole. Okay, so this is how we'll get the moles as 0.01 mole. So we have got the moles of urea, right? And now we have to write the second equation also. This is the first reaction. Now whatever ammonia gas is produced in the first reaction, this will be reacting with the HCl for the neutralization reaction, right? So I am writing the neutralization reaction now. Ammonia will react with HCl to form ammonium chloride, NH4Cl. This is the balanced chemical reaction, right? 1 mole of ammonia will react with 1 mole of HCl to form 1 mole of ammonium chloride, right? Now we have got the moles of urea. So from moles of urea we can find out the moles of ammonia also using the stoichiometric concept, right? If you have 0.01 mole of urea, how much ammonia will be produced? So just go according to stoichiometric coefficient in the balanced chemical reaction. 1 mole of urea gives 2 moles of ammonia. Twice ammonia is formed. Okay, 1 mole is giving 2 moles of ammonia. So 0.01 mole will be giving 0.01 into 2, that is 0.02 moles of 0.02 moles of ammonia. So we have got the moles of ammonia in this reaction, right? Now look at the second reaction. As I told you, for the sequential reactions, whatever mole of ammonia is produced in the first reaction, the same moles of ammonia will be participating in the second reaction, right? So from that part I can write the ammonia is 0.02 mole. Okay, now look at this reaction. From this reaction I can say moles of ammonia are equal to moles of HCl because the stoichiometric coefficient of both are equal, right? So whatever are the moles of ammonia, the same number of moles of HCl will also be required to neutralize the ammonia, right? So from that part I can say the moles of HCl will also be 0.02 mole. Okay, 0.02 mole. So now we have got this moles of HCl, right? And in the options moles are not given directly. We are given with volume and molarity. So how to find out the number of moles from molarity and volume? So let's see. Okay, first of all we have got moles of HCl. Moles of HCl equal to 0.02 mole. Okay, fine. And what is the relation between molarity and number of moles? So molarity, capital M, equal to number of moles divided by volume in liter. Volume in liter. Okay, this is the formula for the molarity. So now if I want to find out the number of moles, we can represent it by N. So if I want to find out the number of moles, it will be molarity into volume in liter. So molarity, capital M, into volume, and volume should be in liter. So multiplying the molarity and volume in liter, we can get the number of moles, right? So we have to check the option. We have to check the options now. In which option we are going to get the 0.02 moles of HCl, right? So let's see. In the first option you have 100 ml. So in liter it will be 0.1 liter. So 0.1 liter into 0.1 molarity, it will be 0.01, right? So this cannot be the right answer for this question. Okay, in the second one you'll have 0.2 liter, 0.2 liter into 0.4 molarity, so it will be 0.08 moles. So this cannot be the right answer, right? In the C option you have 0.1 liter into 0.2 molarity, so this will be 0.02 mole. So yes, this option is the right answer. C option will be the correct answer, right? And in the D option also, this will also be incorrect. 0.2 liter into 0.2 molar, so this will be 0.04 mole, right? So D option is also incorrect. Fine. So that's why the correct answer of this question will be option C. Okay, so this is about the sequential reaction. Now let's see how to solve the parallel reactions and what are parallel reactions. So let's see. Parallel reactions, when same two reactants form two or more products by independent reactions. Okay, so here basically the reactants are same reactants are combining to form different products at the same time, right? For example, suppose I have A plus B reactants. So A plus B are reacting to form C. Similarly, A plus B are reacting to form D. So same reactants are forming different products at the same time. Okay, so these reactions are called as parallel reactions. Now the question is how to solve the questions related to parallel reactions. So again the same thing, very simple. We have to use the basic stoichiometry concepts to solve the question. Okay, and basically here we have two methods. I will tell you about the second method also. So let's understand this reaction by taking an example. So here we have the question: 2 moles of carbon and 1.5 moles of oxygen gas are reacted in a container to produce CO or CO2 both. Find moles of CO and CO2 produced, right? So here it is given that we have carbon and oxygen, both are reacting to form carbon monoxide and carbon dioxide at the same time. Okay, we have to find out the moles of carbon monoxide and carbon dioxide produced in the reaction. So if I write the reaction, so carbon is reacting with oxygen to form CO gas, carbon monoxide gas, right? This is the first reaction. The second reaction, carbon is reacting with oxygen to form CO2 gas. We have to balance these reactions. So this is already balanced. Here I have to multiply with half. Okay, so this is the reaction O2 gas, right? These are the balanced chemical reactions. Now according to question, we have 2 moles of carbon. So suppose, if we suppose that X mole of carbon is reacting with oxygen to form carbon monoxide. So if I take X mole of this carbon, if we take X mole of carbon, okay, then 2 minus X mole will be left, and that 2 minus X mole of carbon will be forming the CO2 gas, right? Because total 2 moles, if X is forming CO, then 2 minus X will be forming CO2, right? Now, with respect to this X, how much oxygen will be used in this chemical reaction? So you can see that 1 mole of carbon is reacting with half mole of O2. So X mole will be reacting with half. X means 0.5x mole of oxygen, and how much CO will be formed? So 1 mole of carbon is forming 1 mole of CO, so X mole of carbon will be forming X mole of carbon monoxide, right? These are the moles based on the X mole of carbon, right? Similarly, for the second reaction also we can do the same thing. Here the stoichiometric coefficient of carbon and oxygen and CO2 also same. So 1 mole of carbon is reacting with 1 mole of O2 to form 1 mole of CO2. So 2 minus X mole of carbon will be reacting with 2 minus X mole of O2, and how much CO2 will be formed? 2 minus X mole of CO2 will be formed. Based on the stoichiometry, we have got the moles of all these 3 species, right? Now, what we can do now? Okay, for the oxygen it is given that we have 1.5 moles of total. 1.5 mole total oxygen is consumed in this process, in these reactions. So if I talk about the total moles of oxygen, total moles of oxygen consumed in this reaction, so that is equal to, according to the reactions that we have written, we have 0.5x mole of oxygen plus 2 minus x mole of oxygen, right? And this will be equal to total moles of oxygen are 1.5 mole. Okay, now if we solve this, we have 0.5 x plus 2 minus x, okay, equal to 1.5. So if you will solve this equation and find out the value of x, it will come out to be 1. So the value of x will come out to be 1 here. Okay, the value of x is 1. So if we have got the value of x, now it is very simple to solve the question now. Okay, so x is what? Moles of CO. So moles of CO are 1 mole equal to x. So moles of CO2 produced are 2 minus x mole. So 2 minus 1, that is again 1 mole. Okay, so we can say that moles of CO and CO2 both are 1 mole in this reaction, in this question. So these are the answers, right? So this was the method 1. This was the method 1 to solve such kind of questions. Using the basic stoichiometry concepts, we have solved this. Now, what is the second method? So let's talk about the second method. Method 2. Okay, this method is using POAC concept. Using POAC concept. And what is POAC? POAC is principle of atom conservation. Principle of atom conservation. So what this principle says? This principle says simply that the number of atoms or moles of atoms in a chemical reaction remains conserved. Means the moles of atoms at the reactant sites will be equal to the number of atoms at the number of moles of atoms at the product site. Suppose in a chemical reaction, suppose in the previous example, if we talk about total number of moles of carbon at the reactant site will be equal to the total number of moles of carbon atoms at the product site. These two will be equal according to this law. And very interesting and important point about this is that you don't have to balance the chemical reaction. When you are using the POAC concept, you don't have to balance the chemical reaction, right? So now what we can do here, we have to write this whole equation together, okay, and we no need to balance this, okay. So let's see. We have carbon which is reacting with oxygen gas to form carbon monoxide gas and carbon dioxide gas, okay, fine. So we are going to apply the POAC concept on carbon as well as oxygen. So if I apply the POAC concept on carbon atom, okay, carbon atom, right? So according to POAC, moles of carbon atom at the reactant sites. So how to find the moles of atoms? Whenever we are finding the moles of atom, we can take the moles of molecule into atomicity of that element, right? Here I have carbon atom only, so I can just say that atomicity is 1. So moles of carbon into atomicity is already 1. So this will be equal to moles of carbon at the product site. So at the product site, the carbon is contained within carbon monoxide and carbon dioxide. So I have to find out the moles of carbon monoxide and moles of carbon dioxide. So NCO, okay, and number of moles of molecule into atomicity of atom. So we are talking about the carbon. So atomicity of carbon in this molecule is 1. So NCO into 1 plus moles of CO2 into atomicity of carbon. Atomicity of carbon is again 1. Now we don't know these values, so we can consider the moles of CO as X mole and moles of CO2 as Y mole. Okay, fine. So we can put the value. Moles of carbon are given in the question, that are 2 moles carbon. So 2 equal to, these are X mole and this is Y mole. So X plus Y equal to 2. So this is the equation 1. Similarly, we can apply the POAC on oxygen atom. If we apply the POAC on oxygen atom, the same thing, total moles of oxygen atoms at the reactant site. So moles of O2 into atomicity of oxygen in this molecule, that is 2. So NO2 into 2 will be equal to moles of oxygen at the product site. So moles of CO, because oxygen is contained within CO and CO2, so we have to write the moles of CO into atomicity of oxygen 1 plus moles of CO2 into atomicity of oxygen, that is 2. So here moles of O2 are given in the question 1.5. So 1.5 into 2 equal to, this is X and this will become 2 into Y, so 2Y, and this is the equation 2. So now we can solve the equation 1 and 2 to get the values of X and Y, right? So if I just subtract the equation 1 from the equation 2, then what we are going to get, this will be 3, so 3 minus 2 is 1, equal to X and X will get cancelled out, and 2Y minus Y equal to Y. So we are getting the value of Y as 1, Y equal to 1. And from the equation 1, you can see that X plus Y equal to 2. So if Y is 1, X will also be 1. So X and Y are the moles of CO and CO2. So again we have got the same answer. So now it is simple. Whatever method you like, whatever method you find easy, you can use any method from these two, either the stoichiometry concept or the POAC concept, and you will get the right answer. Fine. So that's all from my side on this topic. We will be continuing this series. So keep watching the series and don't forget to watch the whole playlist. Link will be given in the description below, right? And still, if you have any query or suggestion, you can tell us in the comment box. Fine. So stay tuned with us. Thank you.